So welcome back, and let's continue with our exponent examples. Let's dive straight in. So we on page 26 and we're looking at this example over here. As always, if you haven't tried it yet yourself, pause the video, try it, and then let it play again to see how we go. Right, let's just quickly remind ourselves that when we've got a product raised to a power, both the factors of the product must get that power. So the 2 must be raised to the power 6 and the 3 must be raised to the power 6. On the denominator, something similar is going to happen with this bracket. We're going to leave the 2 squared for now. That 3 times 2 to the power 3, both the 3 must get a power 3 and the 2 must get a power 3. Now, remember that when we are multiplying numbers with the same base, we're going to add the powers. Let's just look at the denominator first. We've got 2 2's multiplying together over here and a further 3 2's multiplying together over here. 2 to the power of 2 plus 3. 5 2's multiplying together. And over here we've got 3 to the power of 3. Now on the numerator on the top we've got 2 to the power of 6 times 3 to the power of 6. Now remember, when we divide and the bases are the same, we subtract the exponents, right? We've got 2 to the 6 divided by 2 to the 5. That will be 2 to the 6 minus 5. It will be 2 to the 1. We don't need to write the 1, right? And here, the 3's will be 3 to the power of 3. Now, whatever you do, don't go and multiply that 2 by that 3 cubed. That's not a normal 3. Right, so we can't change anything into 6 there. There's our final answer. Okay, right, let's look at the next one. We've got 5 times 7 all cubed. That means that the 5 must be cubed and the 7 must be cubed. And then we are dividing that by 7 squared. Right, now the only ones that have the same bases here are these two, the 7's, that and that. When we divide numbers with the same bases, we are going to subtract our powers. So we're going to get 5 cubed, that's just got to stay there, times 7 to the power of 1. We don't need to write the 1, and there's our answer. Okay, right. If you haven't tried this one, pause the video and try it, and then let it play again and see how we go. Right, so both the 2 and the 5 have to get the power of 8. Okay, 2 to the 8 times 5 to the 8 times 5 to the 4. On the denominator, both the 2 and the 5 need to get that power of 3. Right, now on the numerator, let's multiply those ones that have got common bases, and it's the 2 5's. So we're going to leave the 2 to the 8 for now. The 5's are going to be 5 to the power of 8 plus 4, 12. Right? On the bottom here, we've got 2 to the 3 and another 2. So we've got a total of 4 2's multiplying together, and the shorthand for that is 2 to the 4, and we've also got our 3 5's. Okay, now, when we divide, we are going to subtract our powers. Okay, so the power of 2 is going to be 2 to the 8 minus 4, and the power of 5 is going to be 5 to the 12 minus 3. Okay, right, it's all about just obeying some rules. Okay, now what happens when we've got a fraction raised to a power? Which part of the fraction gets the power? That's right, both of them do. So our answer here is going to be 2 to the 3 divided by 3 to the 3. Now we're multiplying by 3 to the 6 and 2 to the 3. Okay, now we can do some division because we've got 2 to the 3 divided by 2 to the 3. Now, two identical numbers will divide to give 1, right? You might say, but Paul, don't we subtract the powers? Yes, we do. 3 minus 3, 2 to the 0. What is 2 to the 0? 2 to the 0 is 1. Okay, let's look at what happens with the 3's. We've got 3 to the 6. On the denominator, we've got 3 to the 3. When we divide, we're going to subtract. 6 minus 3 gives us 3. Our final answer, 1 times 3 cubed, if we want to, because 3 cubed is fairly straightforward, we should be able to work it out in our head. 3 times 3 times 3, final answer, 27. Okay, the next one has got a product inside here with some numbers with the same bases. Remember, when we multiply numbers with the same base, we are going to add the powers. So we're going to get 2 to the 9, 5 to the 11. Now we're going to multiply this by 2 to the 6 over 5 to the 6. Now remember that this stuff is all over 1. It's kind of, we could write it as over 1. So in fact what we've got is, we've got on the top, we've got basically, that's what it looks like. So on the top we've got the 2 to the 9, the 5 to the 11, and the 2 to the 6. Let's multiply those ones that do have the same base. Alright, and those are the 2 to the 9 and the 2 to the 6. When we multiply and our base is the same, we're going to add the powers. And on the bottom we've got 5 to the 6. Now we've got some division that we can do. We can divide the 5 to the 11 by 5 to the 6. Remember that when we divide, we subtract the powers. So 11 minus 6, 5. Is our final answer. Okay. Right, now what we're going to look at is what happens when we have a number that's raised, a number that's already got a power, and we raise it to another power. So let's expand this. 2 squared cubed. Right, so what we're going to get is we're going to get 2 squared times 2 squared times 2 squared. Now, using our rule where we add the bases, so where we add the exponents when the base is the same, we get 2 to the 6. Okay, so let's do another one. All right, 2 to the 4 squared. Well, that means 2 to the 4 times 2 to the 4. And what is 2 to the 4 times 2 to the 4? If you're not sure, write them all out, okay? How many 2's are multiplying together here? That's right, 4 of them. And here another 4. How many altogether? 8 of them. Okay, but we know that already. We know that when we multiply numbers with the same base, we add the exponents. We want to try and see what's happening here. Can we create a rule for ourselves? When we cubed 2 squared, it was the same as 2 to the 6. When we squared 2 to the 4, it's the same as 2 to the 8. Let's predict. Let's see if we can think about what this one might be before we write it down. Okay, and let's see if we write now. Okay, in other words, what is our final answer going to be? 5 to the what? Okay, I've got an idea, but I've got an idea of what it is. But let's write out, what does it mean to raise something to the power 5? It means to multiply it by itself 5 times. Okay, 1, 2, 3, 4, and 5. Okay, and what's our final answer going to be here? Well, absolutely, it's not going to be 5 to the question mark. It's going to be 5 to the 2 plus 2 plus 2 plus 2 plus 2, or 5 times 2. It's going to be 5 to the 10. Okay. Right, let's look at this one, last one. 3 to the 5 to the power of 4. Right, now, what do we think the final answer is going to be? Okay, it looks like we're going to get the answer by multiplying these two powers. Look at that, 2 times 5 is 10, 2 times 4 is 8, and 2 times 3 is 6. So we think actually the answer may well be 20. Let's write it out in full just to see. Right, something to the power of 4 means multiply 4 lots of that thing together. So 3 to the 5 times 3 to the 5 times 3 to the 5 times 3 to the 5. Right, and that becomes 3 to the 20. Okay, does it make sense? It always makes sense. Right, so when we have a number with a power being raised to another power, we multiply, make sure you fill this in your workbook, we multiply the powers. Okay, and we could write that using variables. We've got a to the power of b raised to the power of c we just get a to the BC, and BC means B times C. Don't worry too much about this as long as you understand the rule in kind of words. So these are the rules that we've got so far, all right? This is the end of all the rules we need for exponents in grade 8. It says here grade 9, grade 8. Okay, when we have the same base and we're multiplying, we add the powers. When we're dividing with the same base, we subtract the powers. If we've got a product raised to a power, both the factors get the power. If we've got a fraction raised to a power, all right, both the numerator and the denominator take that power. And then finally, if we've got a power raised to a power, we multiply the powers. And the very last thing is that by definition, anything to the power of 0 is 1. Okay, right, so now what we've got is we've got loads of examples just to practice in exercise 11. Right, we're going to stop this video here. Before the next lesson, we're going to ask you to have tried all the questions on page 30 and 31, and we'll look forward to going over them next time. Ni ben usuku oluhle.